Let's go ahead and start popping those up. We have Space Gamer on X asks, will there be any more launches for the GOES program after GOES-U, or is this the end of this part of the GOES program?
This is the end of the GOES-R series, and so next up will be GeoXO. So our future geostationary weather satellites will be this GeoXO series, with the first one scheduled to launch in 2032.
That's a ways from now, but the technology on GeoXO, how different is it going to be from GOES-U?
Even more high resolution for the current instruments. We'll have another imager. We'll have the lightning mapper. We're also adding new instruments: a hyperspectral sounder, an ocean color instrument, an atmospheric composition instrument, and that'll give us more information about our environment and our climate.
All right, another question. Let's go to Avincia. She asks, why are the satellites renamed? Why are the satellites renamed once they reach orbit?
That's right. So on the ground, we go by the letters. So this one was GOES-U. Once it reaches geostationary orbit, it'll be renamed GOES-19. It's indicative of the successful mission once it makes it. This is a risky process, and so it gets a new name once it achieves that milestone. And then we have the operational GOES-East and GOES-West positions.
All right, very good. Thank you, Alec. Let's send it back now to Philip Hargrove, who was on a packed balcony during launch with a member of NOAA's leadership. Philip.
Thanks, Daryl. Yes, I'm here joined by the director of NOAA's Office of Space Weather Observations, El Sayed Talat. Thank you so much for being here.
I'm very pleased to be here. Very excited.
Awesome. Yeah. How was the launch? Tell me what your experience was like.
It was fantastic. It was picture perfect. It was beautiful. And the sound was just amazing.
Yeah, really, really was. So we've heard a bit about this compact coronagraph. Can you tell us a bit more about that instrument and why it's important that that's on GOES-U?
So the compact coronagraph, or CCOR-1, is the first operational coronagraph that we're ever going to fly in space. And it's an advanced solar telescope that blocks a disk of the sun so that we can measure the outer atmosphere of the sun, the solar corona. And it's very important to measure that because that's where space weather, extreme space weather events originate. These large explosions off the sun called coronal mass ejections that can send billions of tons of matter hurtling towards Earth at millions of miles per hour.
Right, so it kind of creates its own solar eclipse. I think that's what you told me earlier.
Yes,
right?
Basically this telescope will be able to take a solar eclipse and send it down to the forecasters every 30 minutes, within 30 minutes, okay. So sooner than that. And it'll be the continuous operations of having a solar eclipse basically within 30 minutes continuously.
And can you tell me about how this instrument works with the other instruments on board?
So what this instrument does, it allows us our long-term forecasting in space weather. So 1 to 4 days after we see an explosion off the sun, we measure the characteristics of these explosions and put it into our models that propagate it towards Earth and see if it's going to come towards Earth, and then estimate how big the impact is going to be. And we really need to know that because that's important to protecting our technological infrastructures. These solar storms can affect the power grids, civil aviation, and other satellite operations, as well as communications and navigations. And this works in tandem with the other solar instruments on board that measure the solar and EUV, X-ray and EUV irradiance, and image the sun. And then the imagery of the sun gives us the context imagery of the sun that is basically like looking at the Atlantic basin for tropical cyclones as they develop, and then they might develop into hurricanes. We look at the sun with the solar ultraviolet imager to see if these regions of activity, which are centered around sunspots, if they're going to develop and produce flares and explosions, these coronal mass ejections. And we measure those effects with the irradiance measurements and the particle instruments that we have on the GOES satellites.
Very interesting. And then what's next for NOAA with regards to space weather prediction?
So it's a very exciting time for space weather because we're developing, enhancing our capabilities. We are going to fly next year, in 2025, the Space Weather Follow-on L1 mission that is going to be an upstream buoy for measuring the solar wind and incoming solar effects 1 million miles upstream of Earth towards the sun.
Very exciting stuff. Thank you so much for being here, and I'll toss it back to you, Megan.
Philip, Meg and I, again, are back here at the Mission Director Center at Hangar AE on Cape Canaveral Space Force Station, and we continue to monitor the teams as they continue the journey to deliver GOES-U to its correct orbit around the Earth.
Yeah, things are going very well. That first burn, all the telemetry looked very good. Nominal, the vehicle's in a coast phase right now. Our next step coming up will be SES2, that second burn, which we should be hearing here in about 25 seconds. Things are progressing well, and GOES-U looks very good.
Again, the milestone bar at the bottom of your screen is where we are in the milestones to getting GOES-U into its correct orbit. SES2 is that second burn that we're talking about, and we're tracking that for 26 minutes and 19 seconds. So 5 seconds from now. All right, and there we go. We see the MVAC engine on the Falcon Heavy second stage lighting up. This is the second of 3 burns for this engine. This burn is going to last about 1 minute and 27 seconds.
Things are going very well with the launch vehicle as they are on this trajectory that Mark Hammett's talked about, raising that orbit up to where we need to get going for that coast phase to head out to geotransfer. So things are looking very well, and all the telemetry on second stage is performing good. Our MVAC is performing very well, and telemetry looks like we are heading in the right direction, and vehicle's performing nominal.
The image that you're seeing right there, an animation, again, of where we are, the trajectory that we have been keeping an eye on, and as you said, that we had an interview about earlier in the broadcast.
Yep, we are about 20 seconds from SECO 2, and the vehicle is progressing in a good velocity, stage 2 velocity, and putting GOES-U where it needs to be and making that adjustment in the trajectory that Philip and Mark talked about. And things look good as we're getting ready for MVAC shutdown here in about 5 seconds. Things still progressing well. And there we see MVAC shutdown, and we are beginning this coast phase. Megan, things look good on the vehicle as we are watching the telemetry screens here from SpaceX. The vehicle performed very well during that burn. And there we heard the call out for a nominal transfer orbit, and we get ready for this long coast before our third burn.
Absolutely, a long coast phase. We're looking at a coast phase of about 3 hours and 53 minutes. Again, this is a very well choreographed to the second trajectory that gets us to that geostationary transfer orbit that you're talking about. LSP's mission is to deliver GOES-U to that geostationary transfer orbit. And while it's there, they're going to do some checkouts of the satellite. And then once operational in geostationary orbit, that is where GOES-U becomes GOES East, and we'll keep a continuous watch over the Western Hemisphere.
Yeah, as we get GOES-U on its way today, things progressing forward. As Alex said, it's very exciting to see the liftoff of the Falcon Heavy with GOES-U. Second stage is performing very well on that, and as we can see on the screen there, that stage 2 is coasting where it needs to get to, that normal geotransfer orbit insertion that we've heard about from Mark and Philip, and things are going to progress very well as the vehicle orients itself and gets GOES-U oriented on its way for that third burn, which will be a very important burn to finalize the mission to get ready for deployment. And part of that would be that the Falcon Heavy performed so well today that will that extra performance we had will give GOES-U a little bit of extra life on orbit because they don't have to use as much spacecraft fuel to get to geostationary. So vehicle performance looked very good today.
Yeah, GOES-U the GOES satellites are designed to have 15 years of life, but because we are saving propellant on the spacecraft, because Falcon Heavy is delivering it farther towards this orbit, we are looking at a 20 plus
Almost
year
20
life.
years,
Yep. So again, just any other check of the spacecraft before we sign off for a little bit for this coast phase, Mick?
Nope, everything looks good on the spacecraft side. They are operating on batteries. As Mark said, they are on the right trajectory with the sun in the right position to get ready for deployment. And after deployment, they'll get some of their solar arrays out, partial solar array deployment, to be able to charge those batteries and get going, and then begin their work in the next few weeks to get to geostationary.
All right, so again, a coast phase of just under 4 hours. Mick and I are going to pop in at the top of every hour, so 7 and 8 o'clock p.m. Eastern Time, to give you some quick updates about how everything's going. But for now, let's toss it back to Philip.
Thanks, Megan. Yes, I'm here with the NOAA administrator.